My presentation is on nest site selection in Northwestern pond turtles, Actinemes marmorata. You guys heard a background earlier from Dave, and I'm just gonna repeat information. Their historical range spans across Western North America, so from British Columbia, Canada, down to Baja, California, Mexico. Their conservation status varies within the United States. In Washington, they are endangered. In Oregon, they are threatened. And in California, they are a species of special concern, but actively under review to become federally listed. They are California's only native freshwater turtle. There are two subspecies, the Northwestern pond turtle and the Southwestern pond turtle, and they are a temperature-dependent sex determination species, specifically type 1A. So when eggs are incubated in cooler temperatures, it results in males, and when eggs are incubated in warmer temperatures, it results in females. They face a variety of threats, including habitat fragmentation and urbanization, invasive species like red-eared sliders and bullfrogs, and then climate change, such as droughts that can lead to mass die-outs and reduced reproduction. So what is nest site selection? Nest site selection is the non-random placement of nests or eggs by a female turtle to maximize her chances of nesting and successfully produce offspring. The aim is that optimal nest site selection minimizes the mortality of females and maximizes their reproductive success. It has not been proven in Western pond turtles, but the literature seems to suggest that they might have preferences. Nest site selection is considered an environmentally flexible response. It can impact a female's survival and their nesting success. It is a critical behavior in turtles because once those eggs are laid, there is no parental care. So the only chance a female has at passing down her genes is by selecting a nest site that leads to the success and survival of her offspring. It's considered a mostly plastic response with likely low heritability, meaning it's based on environmental cues and individual experiences rather than on genetics. So with it being a flexible response, females can adapt and respond to short-term conditions, but it doesn't easily evolve over generations. So a female turtle that's able to select a good nest site, that doesn't mean that her offspring will inherit that same ability. And then lastly, it can be constrained by inherited nest site fidelity. So females may stay loyal to a site that might not be as successful as other sites due to this nest site fidelity. Nest site selection is important because where they nest is going to define those moisture and thermal conditions that are going to define offspring sex ratios, their survival, and their overall fitness, which is their performance, so their locomotion, ability to swim, their morphology, so their size and limb proportions, their physiology, so their metabolic rate, their growth rate, their behavior, so boldness and dispersal. It's going to reflect the ecological pressures in the habitat, which is going to be influenced by both biotic and abiotic factors. So that's going to influence the risk of depredation and inundation on the nests, the chances that the hatchlings reach the water after emerging, as well as the survival of the nesting females. So selecting the wrong nest site can have detrimental consequences to both parent and offspring. Next, I want to introduce you to my study. My field site is in Livermore, California. It is a 5,000-acre cow-calf operation that's grazed year-round. It's owned by Zone 7, the water agency, but leased by the Banke family. It is a spring-fed perennial stock pond. It is a silty clay loam soil that is there that directly surrounds the pond, and it is steep terrain. There are 45 to 75% slopes. And there have been 0 Western pond turtle studies at this site until we began our research. But the pond is amazing and full of life. We have a lot of large red-legged frogs. We have killdeer that nest every year. We've seen the successful recruitment of the Western pond turtle, so we see the hatchlings. We have no red-eared sliders, and we have no bullfrogs. Now I'm going to take you through my June 2024 and 2025 nesting season. So I'm going to break down this very colorful map that you guys are seeing. So in 2024, we had 20 successful nests, which are in green. In that same year, we had 11 failed nests, which are in red. And we also had a double clutch that year. So our first female to nest was also our last female to nest. She nested on June 6th and then again on June 26th. In 2025, in blue, we have 23 successful nests, and that year, or this year, we had 6 failed nests in orange. So in total, I had 43 successful nests and 17 failed nests. I collected nest site characteristics for all of these. In 2025, I introduced soil sampling for all of those successful and failed nests. In order to properly study and understand nest site selection, I deployed 50 random sites to sample. And so I collected nest site characteristics at all of these sites, including soil samples, in order to compare the sites that they're not nesting at to the sites that they are nesting at. So what does the literature say? Most published studies have been limited to descriptive accounts, and so it suggests that females prefer to nest on well-drained clay-sit soils with a slope of less than 15 degrees. For my preliminary data, on average, I found that our aspect was northeast facing, so about a 72 degrees. Our slope was 22.99, so well above that 15 degrees, but remember, this is very steep terrain. Distance from pond was 49.87 meters. The furthest nest was 161.5 meters away. However, western pond turtles are always nesting within a water source. So distance from water was 23.76. So that's whether they're nesting near the pond or those 3 creeks that connect to the pond that are also available to them. So distance from pond is just going to reflect the female's movement, while distance from water is going to reflect the habitat that the hatchlings are going to utilize once they emerge. And then lastly, our distance from canopy cover was 14.58 meters. For my preliminary data, when comparing successful nests to random nests, I found that western pond turtles select sites non-randomly, choosing distance from water and distance from canopy cover, and in soils with specific moisture and bulk density. So as you can see on the photos on the bottom, the image on the left is the north-facing hill, where a majority of the nests were laid, and you can see that there is a variety of canopy cover there. Or if you look at the image on the right, that is the south-facing aspect, and there's very limited canopy cover, and there are no nests that occurred there. So this is fantastic, because now we can actually prove that nest site selection is occurring in western pond turtles and what habitat characteristics they are selecting for. I do want to point out that at our field site, slope and aspect did not matter. Diving deeper, I found that when comparing successful nests and failed nests directly, only soil moisture and bulk density differed, indicating that that soil microhabitat is what predicts nesting success. So that soil moisture and bulk density is going to depend on whether the females are able to excavate and lay their eggs, or if they end up digging for hours and then bailing because that soil is just too compact for them to dig in. I also found that at a population level, the females altered their nest site placement between 2024 and 2025, and that canopy selection was actually driven by low temperatures for the successful nests. This could be due to a cool temperature risk. So we know that the females leave in the evening to nest, they stay on the nest overnight, and then return to the pond the next morning. So they could be assessing that microclimate to see how that might impact their behavior overnight. And we know that there's limits to embryo development and their sex ratio, so cooler temperatures result in males, so maybe they're assessing that microclimate to ensure that those clutches aren't going to be male-dominated, because you need females in a population to survive, especially as a long-lived species. So these results show that all females may shift their nest site behaviors across years, but only the successful nests reveal a consistent thermally guided habitat selection, which makes sense because they are a temperature-dependent sex determination species. And then lastly, I found that western pond turtles that nest further from water nest closer to canopy. So in 2024, they nested closer to the pond and further from canopy, but in 2025, they nested further from the pond and closer to the canopy. So overall, it appears that canopy is playing an important role in nest site selection, likely as a thermal buffer. Western pond turtles are a plastic species, so it can lead to variation in their behavior, and this could be due to a variety of reasons, such as environmental conditions. 2024 was a lot hotter, and it received more rain that year. 2025, our nesting season was freezing. It was really cold this year, and it's been a lot drier. Cattle pressure presence could have changed. In 2024, it seemed like the cattle were there more often. Again, it's probably because it was hotter, so they were trying to utilize the pond more often as a resource. I do want to point out, so there's no questions on it either, I have not seen turtles trampled by cattle, and I have not seen nests trampled by cattle either. Predator pressure can also be an influence. However, this doesn't feel likely at this field site because we had 0 nests depredated both years. And then lastly, human disturbance plays a role. So 2024 was their first exposure to us. We were tracking them, manhandling them. 2025, they were getting used to us. We did notice an overall shift in their behavior, and it's hard to say whether that's on us or other conditions or everything put together. But in 2025, there was a lot more social facilitation that was happening. I noticed that on average, they were leaving in groups of 3 to 4 from the pond. They would go up to the pond edge together. They would look at each other. One female would decide to leave, and then the rest would immediately follow her. And most of the time, they were nesting within 1 meter of each other, which was pretty interesting. Did not happen in 2024. We do have 2 new grad students. We have other current projects going on. We have temperature-dependent sex determination happening. So we put temperature loggers in the nests this past summer. We put them in 15 nests. When we went to pull them, all the turtles had hatched, and so when we took off the nest plug, a hatchling went running, and we didn't want to disturb them because they overwinter, so we just popped the nest plug back on, and we'll be pulling the loggers in the spring. And then we were also looking at nest site fidelity. But all of this to say is that this research is important because it fills the knowledge gaps on nesting behavior in western pond turtles, which is an underrepresented species in conservation and in research. It allows us to examine site-specific differences across habitats, which allows us to gain insights into their ecological flexibility and adaptability. It can directly support local land managers by helping them make informed conservation decisions. And overall, it's promoting collaboration between researchers and ranchers. What's important is that protecting turtles means protecting entire ecosystems. Nest site selection is a very critical part of reproductive success, but has been historically under-researched. A 2023 review paper on nest site selection in freshwater turtles went through hundreds of turtle papers and only found 35 on nest site selection. And most of those 35 papers were on sea turtles and not freshwater turtles. So setting this up was like a work in progress, trying to go through the very limited research. But this not only improves our understanding and our knowledge on western pond turtles, but also contributes to the greater efforts of freshwater turtle conservation. I cannot do this project without so many people. Farley and Jackie from the NRCS and the ACRD were huge components to this project, and my advisor. A big thank you to the Binky family for allowing us onto the property. Of course, thank you to Save Mount Diablo. I would not have a thesis without you guys. But overall, so many people that worked on this project made it happen. Thank you.
Thank you, Madie. Any questions?
Just a simple question. How do these turtles get introduced into these ponds?
Well, turtles can actually disperse very far, and their range spans across all of Western North America, and they used to be a lot more prevalent as species. So we've killed off the population by millions through turtle soup just within the Bay Area. But these ponds connect to greater water ecosystems. So we've had turtles that have completely left these ponds. They went up a creek, over a ravine, entered a reservoir, and then went up another creek. So they've traveled more than 5 miles. Yeah, my advisor likes to call them all-terrain vehicles.
Another question.
What's the distribution by sex in the population in your study area? And also, can males impregnate more than one female? Have you been able to determine that?
So our sex ratios are pretty even. Our population sits around 50-60 individuals, and it's pretty split in half between males and females. And then what was the second part? Yes, yeah. So I don't know how often that's been looked at, and if there's like a dominating male that more likely reproduces than other males. It's more likely we do have some really large males compared to the other males. So it's likely that they might be the ones that are more successful in reproducing.
I was curious, you had mentioned about the overwintering of the juveniles, and could you expand a little bit more about the life cycle of these turtles?
Yeah, so females tend to nest during June. They can go into July. It's going to depend on both like the environment and warmer temperatures. So warmer temperatures are going to speed up their gonadal cycles, but they also have to have enough like nutrition and resources to allocate to that. So that's going to dictate nest timing. And then when they nest, they incubate for 90 to 120 days. In the northern population, the hatchlings stay in the nest, most likely to avoid the more extreme weather that we exhibit here compared to the southwestern pond turtle. The southwestern pond turtle doesn't overwinter, so those hatchlings just emerge. And then those hatchlings will emerge come spring, so most likely around April time when we start getting warmer temperatures again.
Yeah, I was curious about this social facilitation that you mentioned. Do you have data on who was leading those female groups that you mentioned and versus who is following? Are there any characteristics that determine that?
It's really hard to tell who's who leaving the pond. What we could do, and we've done it for hatchlings, is you color code them with a marker. So we could do like a color code on their shell, so when we can see through like the binoculars who's leaving first, and that's not a bad idea. But no, I haven't done that. I do like, when they leave at staggered times, they pick a general direction to go in, and I kind of like note the direction, and then when I go to check on them in my head, I can like figure out for the most part who was who, based on the direction and where I find them. But that is a smarter idea.
Any other questions?
I'm curious about, we've been trying to document them on some of our local stream systems, and we've had success with photographing a few. And do they nest on running water stream systems, or do they need a actual pond to nest there?
No, they won't need a pond. If you're looking at it like a creek setting, they'll just move upland from the creek to find habitat to nest in. So it's not like they need a giant water source like a pond. Yeah.
But they would have similar travel distances, you would expect?
Yeah, it also depends is it like an urban creek?
Urban creek, but it's a very large open space area within an urban area.
Okay, then probably they'll stay within like the confines of that. You get into the issue of more urban settings with reducing their habitat, so then that's when they go and venture, and then now they're crossing roads and going into neighborhoods and trying to find more suitable habitat, which is also maybe playing a role in the distances that they're traveling. But if you have available suitable habitat, it's likely that they're staying within that area.
Thank you again.